Okay, so here we're going to go through the acid catalyzed mechanism for the formation of the hydrate of a carbonyl. It could be either an aldehyde or a ketone. We'll start with the aldehyde that we did in the last video. And so here we are going to take the aldehyde, and now we're going to do acid catalyzed hydration. So we're going to use just hydronium ion and H2O. That's all we need. And then we're going to make the 1,1 diol for the product, or it's the gem diol for the product there. So the way this works is, as opposed to the last mechanism, instead of pushing a nucleophile into the carbonyl carbon, we're going to use the electrophilic source of H plus, or hydronium ion. And since that's the electrophile, the carbonyl electrons will be the nucleophile. Go after the electrophile, and we've got our first intermediate. So this oxonium ion does not like having a plus charge on the oxygen there, so we'll do a resonance contributor. Best nucleophile goes after best electrophile. And that will give us the plus charge on the carbonyl carbon. So that is now our next electrophile. So we're going to take that, we'll add water into it. It's a very good electrophile, so we don't need a minus charge on our nucleophile. As a matter of fact, we don't need our minus charge on our nucleophile because over here, since this is acid catalyzed, we're going to put a plus sign in the circle here. And therefore, no place in the mechanism should there should be no appearance of a minus charge at all in the mechanism. All plus charges or neutral, but no minus charges. So that's why we're going to use this neutral water as our nucleophile to go after our electrophile. That gets us to our next reactive intermediate, which looks like this, which has an oxonium ion with plus charge in the oxygen, which we don't like. So plus the protons on that water molecule have now dropped to -2, -3, so they're really, really acidic. So any base, any general base, is going to come along and deprotonate, pull the electrons off, give them back to the electron, to the oxygen for the lone pair, and that will give us finally for our product the 1,1 or Gemini twins, the gem diol there. And so then you can look at the plus sign in the circle here, and you can do a quick scan of your mechanism and say, okay, so I got plus charges, I got plus charges, I got plus charges, I got plus or neutral, no negative charges. That's a really good sign that you have a really good, valid mechanism. If there were any minus charges in this mechanism whatsoever, that would be a sign that you have a problem, that you went wrong somewhere in the mechanism. Okay, so that's the acid catalyzed mechanism for the hydration of a carbonyl aldehyde or ketone to make the gem diol.